Just a minute, student. Last time, in the last class, we were discussing one problem. And you know the problem. What was the problem? You know what was the problem? Do you know the problem? One student has asked the question regarding like transition matrix. Okay, transition matrix problem. So have you understood the transition matrix? What is the transition matrix and how to solve that problem? Have you understood? No. Okay. So first of all, I am going to teach you the transition matrix problem. Then we will go to the next problem, whatever you are asking. Done. Chaliye. So for transition matrix problem, let us consider you have a problem like problem number 1. I am saying T is a linear transformation. Okay. Yes. Question, I am giving one question. If the matrix of a linear transformation T on R2 to R2 with respect to basis B is equal to 1 0 and 0 1 is, then what is the matrix? The matrix. What is the matrix of T with respect to ordered basis B dash 1 1 1 minus. This is the problem. Student, what the question is saying, just understand the question first of all. Let us consider you have a matrix of a linear transformations, and with respect to given this basis is matrix is given 1 0 0 0 1 like this is the standard basis. With respect to this standard basis, the problem is 1 1 1 1. The question is, what is the matrix of T with respect to ordered basis this B dash, which is 1 1 1 and minus 1? Should we try? Yes, you can try. First of all, just try and tell me how to find out the answer. Then I will tell you the what is the procedure to find out the answer. I am giving you 2 minutes. So now, yes, मैंने timer start कर दिया, फटाफट solve कीजिए. Ranshu, yes, wait, sir, it is coming. Okay. 2 0 0 0. Very good, Manoj, you are right. Manoj, you are right. How did you find out, Manoj, the answer? आपने पढ़ लिया नहीं? Yes, you have studied this thing from the book. What is the transition matrix? See, basically, let us consider when the linear transformation is given. When, अच्छा पहले आप बताइए, Manoj, yes, you can speak. How did you find out the answer? Yes. Can you tell me how did you find out the answer? When
पहले तो ये लीनियर ट्रांसफॉर्मेशन का फॉर्मूला निकाल लिया, फिर ये इस बेसिस बी डैश बेसिस से मतलब निकाल ली मैट्रिक्स.
What is the formula of linear transformations?
X plus y, X plus y.
How did you find out this one?
Sir, फर्स्ट एक्स वाई इज इक्वल टू ए कोमा ये बेसिस रख दिए, फिर उन पे मतलब लगा दिया। सर ये आपने मतलब करवाया हुआ है ये क्वेश्चन, मतलब फॉर्मूला
Okay.
निकालना तो आपने
See.
सिखाया था।
कुछ ये था कि if you have with respect to any basis you can write down t10 is 1 1 ना, that is a times of 1 0 plus b times of 1 1 0 1. This is the main na, this is the meaning of what is t10? T10 is 1 times of 1 comma 0 plus 1 times of 0 comma 1. This is the problem na. By this is the meaning, and t of 0 comma 1 is 1 times of 1 comma 0, and you are saying 1 times of 0 comma 1, because this is the if you have linear transformations and you convert the ordered basis with respect to this basis, this is a matrix, then you can write down like this. Okay, so what is this? 1 comma 1, and that is 1 comma 1. So if somebody say t of x comma y, that can be written as x times of 1 comma 0 plus y times of 0 comma 1. So that is x times of t, sorry, x comma y is can be written as t of this one. So that is y of 0 comma 1. So that is x of, that is y of 1 comma 1. So linear transformation, you have find out the linear transformation x plus y comma x plus y. This is the problem. So student, earlier I have told you if there is a linear transformations with respect to ordered basis, मैंने बताया था ना, तो you can directly find out the linear transformations. Yes or no? मैंने ये बताया था, if there is a like matrix, so you can find out tx equal to ax. That बता दिया था ना मैंने. It means x मतलब that is x comma y. So what is the answer? X plus y, x plus y. But just understand, this problem is only valid, this tx equal to ax is only valid for when you have a linear transformation with respect to the ordered basis, standard ordered basis. You can write down this tx equal to ax. Otherwise you have to find out like this, whatever way I have find out. Is it clear? So linear transformation of txy is nothing but x plus y, x plus y. Okay, so this is the linear transformation. It means this is some extra work which we have done. In general, txy is given and two ordered basis is given, so you can find out the answer. Now somebody is saying what is the matrix with respect to this ordered basis, so you can find out directly. But I want to tell you one thing. Generally the rule is you can you find out directly. Yeah, txy is given. Now you can solve the problem with respect to b dash. B dash means you will find out ordered t of 1 comma 1. You will find out t of 1 comma minus 1, and you will write down t of 1 comma 1 and 1 comma minus 1 in the linear combination of 1 1 and 1 minus 1. Then what are the coefficients you will have? Then you can form a matrix that is called the matrix with respect to the ordered basis b dash. But directly, if there is a question you can solve directly also. If T is a linear transformation from some vector space U to V, and with respect to some basis B, dash, you have some matrix T of B dash. Okay, this is called TB dash. With respect to B, you have TB to B and B both side, and with respect to B dash, you have B dash to B dash. Okay, B dash to B dash, generally we write down only TB dash, TB dash. Okay, so what is TB dash? T with respect to B dash is equal to P inverse TB, where P is transition matrix. from B to B dash. Is it clear? I think you had doubt in this problem. I think किसी ने मेरे से पूछा था इस प्रॉब्लम का डाउट, सर इसका आंसर बता दीजिए in the last class. That's why I have it is the
Sir?
concept of diagonalization. No, this is not the concept of diagonalization. This is the concept of similar matrix. Because when you have some linear transformation, just think, when you have some linear transformation, so generally what you do when you find out the matrix, you put the simple standard basis and you find out some matrix and find out the eigenvalue, eigenvector, all this kind of thing, randomity, whatever you need. But if somebody gives some ordered basis, not standard basis, then you have to find out with respect to that basis. But answer is not different. Why answer is not different? Because whatever we found out that is linear, that is eigenvalues, eigenvector. So similar matrix has similar eigenvalues. If eigenvalues and eigenvalue you have, you trace, determine, all these kind of things you can find. Yes, tell me.
सर
Yes.
जो आपने समझाया वो तो मैं समझ गया। मेरे पास एक कंसेप्ट मैंने पढ़ा था, तो आप मेरे को बता दें कि सही है या गलत है।
बोलिए।
एक्चुअली एक मैट्रिक्स दिया हुआ था और उसके सिमिलर एक और मैट्रिक्स अगर हमको फाइंड करना है, तो हमने पहले उसके सारे आइगन वैल्यूज निकाल लिए एंड आइडेंटिटी एलिमेंट के प्लेस, जैसे आइडेंटिटी में 1 1 1 लिखा होता है ना, उसके प्लेस पर हम लोगों ने वो डिफरेंट जो भी आइगन वैल्यूज आए थे वो डाल दिए। तो क्या वो मैट्रिक्स सिमिलर होगी उसके?
मतलब एक मैट्रिक्स, दोबारा बोलो।
एक मैट्रिक्स थी कोई भी,
मान लेते हैं ए मैट्रिक्स है,
इसके मान लीजिए 3 क्रॉस 3 की, मान लीजिए इसका हमने आइगन वैल्यूज निकाला λ1 λ2 λ3।
ठीक है, मान लिया 3 आइगन वैल्यू आ गई।
एंड अब हम लोगों ने एक और मैट्रिक्स बनाई, उसमें हमने लिखा λ1 0 0 and 0 λ1 λ2 0 and just like this.
These are 3 eigen value I have taken.
हाँ, तो क्या ये मैट्रिक्स जो बनी है ये गिवन मैट्रिक्स के सिमिलर होगी?
बताओ भाई। यस, बताइए, बोलिए, क्या ये गिवन मैट्रिक्स के सिमिलर होगी? आपने तो ये मैट्रिक्स को डायगोनलाइज बना दिया। हो सकता है ये मैट्रिक्स की, फिर तो आप ये कह रहे हैं, मैं आपको बता दूं
सर, एक्चुअली ये मेरा कोई रिसर्च नहीं, मैंने कहीं भी पढ़ा था एक्चुअली।
कोई बात नहीं, पढ़ा कुछ और होगा, समझ कुछ और लिया होगा।
हाँ सर, इसलिए
मैं ये मानता हूं कि 3 आइगन वैल्यू 1 1 1 है। ठीक, 3 आइगन वैल्यू 1 1 1 है। कैन यू राइट डाउन लाइक दिस, डायगोनल मैट्रिक्स इक्विवेलेंट?
सर एक्चुअली उसमें तीनों के तीनों डिफरेंट आई थी।
तो डिफरेंट है तो सीधी सी बात है, डायगोनलाइजेबल मैट्रिक्स है। डायगोनलाइजेबल मैट्रिक्स है तो इस मैट्रिक्स को इसके सिमिलर लिख सकते हैं डायरेक्ट, दैट इज ओके।
अच्छा
भाई सीधी सी बात है, इफ यू हैव ए मैट्रिक्स which has distinct eigenvalues, it means matrix is diagonalizable, and matrix is diagonalizable, it means the matrix A is A can be written as a P inverse AP. And what is this diagonal matrix? The diagonal matrix is, this is similar to this A, so diagonal matrix has same eigenvalues. So what is the diagonal matrix? Diagonal matrix is ABC. So how can you say this is similar? It means ABC are the eigenvalues only.
yes. Even though we can write something else, और ऊपर जो 0 0 जो पोर्शन रह गया है, ट्रायंगल पोर्शन ऊपर वाला या नीचे वाला, किसी एक और वैल्यूज भी पुट कर सकते हैं ना? नहीं
कर सकते। क्यों कर सकते हो?
तो
when you are saying the matrix is diagonalizable, the meaning is this will similar to diagonal. See, similar matrix is different. Similar means that may be diagonal, no, that may not be diagonal matrix. In that case you can put something else also. But when you have a matrix is diagonalizable, that is similar to diagonal matrix, and that diagonal matrix is nothing but you will replace all the elements as an eigenvalues, and you will have so many possibility of the diagonal matrix. ऐसा भी हो सकता है कि आइगन वैल्यू 1 0 0 आ जाए, मान ली 3 आइगन वैल्यू है, या ऐसे भी हो सकता है 0 1 1 आ जाए। ठीक है, बिकॉज डायगोनल, दिस इज आल्सो डायगोनल, है ना? Okay, like this.
Yes sir, got it.
Possible, because all these are similar also. Okay, yes.
Yes sir, got it.
Yes. Any other questions? You are asking? Yes. One student. How to find a basis of W1 plus W2 and W1 intersection W2. Okay. How to find out the basis of W1 plus W2? See, question number 3. How to find out basis of W1 plus W2 and W1 intersection. See, W1 plus W2 is generated by, that is L of union W1 plus W2. It means this is generated by W1 union W2. So you have basis of W1, you have, take basis of W2. Okay, and find out the union is generated. Now you have to eliminate the linear independent element. Let us consider this has 3 elements, this has 3 elements. Put in a matrix. If this is a Rn type, put in a row echelon form, okay, like this, and convert into the like maximum possible linear independent set. It means you will apply the row echelon transformations, and make the matrix as elementary row transformation matrix. बनाने के बाद आपके पास जो भी मैट्रिक्स आएगी, जो उसमें रो आएंगी, लाइक यू हैव 3, like 6 में से 3 4 बच गए, तो it means that row will be form the basis of W1 union W2. Is it clear? Yes, Pranshu, tell me.
Sir, I have a question. Change beta dash coordinates into beta coordinates.
एक मिनट पहले ये वाला क्वेश्चन कर लेते हैं. Thanu, is it clear? Basically, you have a, if you have any question, Thanu, we can discuss. We have W1 basis, W2 basis. So W1 basis, W2 basis, you will put in a row.
Sir,
That is the linearly that is generated set. You will eliminate the linearly dependent element or vectors. Yes.
sir, I have a question regarding that. Can I give you, sir?
Yes. Yes, you can speak. फटाफट बताइए.
Yes, sir. Suppose W1 and W2 are the subspaces of psi power 4 spanned by
Of subspaces of
psi power 4. Psi.
I.
Yeah, it's a set of all real numbers.
Psi or R?
They have mentioned the function as psi power 4, and in bracket they have said that it is a set of all real numbers.
Set of real numbers.
Yeah.
Okay.
Which is spanned by 1, 2, 3, 4. One vector. 2, 1, 1, 2. Second vector. This is. And 1, 0, 1, 0. 3, 0, 1, 0. Respectively.
Like this. This is this set. Different set.
Yeah. First two vectors are spanned by W1, and second two. Yeah. Find the basis of W1 intersection W2. Also find the basis of W1 plus W2 containing 1010 and 3010.
What you are saying next?
Which containing 1010 and 3010. That's second set.
which matlab, which one? The both W1 intersection W2 and W1 plus W2.
They have mentioned find the basis of W1 intersection W2 and
Yes,
also find the basis of W1 plus W2
which containing
1010 and 3010.
okay. Done. So question is, as the Thanu is saying, the question is W1, W2 are two subspace of R raised to power 4. Confusion, this is confusion, okay, not set of real numbers. Suppose W1, W2 are two subspace of R raised to power 4, and W1 is spanned by 1, 2, 3, 4, 2, 1, 1, 2, and W2 is spanned by 1, 0, 1, 0, 3, 0, 1, 0. So question is find the basis of W1 intersection W2 and W1 plus W2, which contains, the basis contains 1, 0, 1, 0 and 3, 0, 1, 0. Number 1. See, which contains this basis. Okay, no problem. First of all, W1 plus W2. Okay, W1 plus W2. This is generated by W1 union W2. As I have said, you have to find out the basis. How to find out the basis? Take both the bases and put in this form. 1, 0, 1, 0. Okay, why I am writing 1, 0, 1, 0, 3, 0, 1, 0? Why I am writing like this? I am writing like this. Why? Because we have to include this one as in the basis. We will not eliminate this. We will not make this as 0. Basically, it may be that na, this will be eliminated and that will be 0. But we will not eliminate, so we will put that row into the top. 1, 2, 3, 4. 1, 2, 3, 4. And that is 2, 1, 1, 2. 2, 1, 1, 2. Now apply row transformation. 1, 0, 1, 0. 3, 3, 0, 1, 0. 3, 0, 1, 0 नहीं, हम ऐसा करते हैं, इन दोनों रो को रखेंगे. We will put that row, but what I am doing 3 times, that is minus, so that is 0. Okay, so what we are doing? We are doing numbering 1, 2. ये W1 की है, W2. This is W1, 3, 4, and this is W2. 1, 0, 3, 3 times R2 minus 3 R1, 0, R2 minus 3 R1 minus 2, 0. Yes or no? R3 minus, okay, okay, 1, 2, 3, 4, 2, 1, 1, 2. What I am doing now? I am saying we have not changed this row. Exchanging is not, we have not done exchanging. No problem. So 1, 2. So 2, 1, 0, 1, 0, 0, 0, minus 2, 0. And next is R4 minus 2 R1, 2 R2, 2 R3. You can write down, but what I'm writing, just take this. This is 2 minus, that is 0, R4 minus 2 R3. R4 minus 2 R3 minus 3, 2 R3 minus 5, 2 R3 minus 6. So this is okay. Okay. Yes. So can we make some other? Okay, what we are doing, we will do this kind of things, which we have to do. W1, 0, 1, 0, 0, 0. Okay, we will swap this one. So that is okay, 1, 2 कर लेते हैं. 1, 2, 3, 4, 0, minus 3, minus 5, minus 6, 0, 0, minus 2, 0. So now this is star and this is star. This we have to take. Okay. So can we do something else also, so that we can make our transformation as 0? This is R2 minus R1. Further we are doing. Okay, 1, 0, 1, 0. R2 minus R1. R2 minus R1, 0. 2 2 0 2 2 4 0 2 2 4. So why we are writing 0 2 2 4? We are writing 0 1 1 2. Yes or no? Finally we are 0 minus 3 minus 5 6. So 0 3 5 6 5 6. And what is this? This is 0 0 minus 2 0. So that is 0 0 2 0. Okay. What we are doing further? This is star, and this is also star. 1 0 1 0 0 1 1 2 0 0. 3 times, that is 2. 3 times, na? 3 times are 3 minus 2, 3 are 2, and 3 times, that is 0. Okay. 0 0 2 0. So finally, this is also star, this is also star. So what I'm saying, 1 0 1 0 0 1 1 2 0 0 0 0 कह रहा हूँ मैं, और 0 0 0 2 2 0. We are not eliminating this one because this is our main product. Okay, these two are main product. This, because we do not have to delete this one. So finally, this is, but which, okay, which we have swap, we have to check one. Okay, we have to give numbering also, na? But ये numbering की problem आएगी, otherwise ये problem has been solved. 0 1 1 2 0 0 2 0 0 0 0. So this is the row first and third. So this row, what is this row? Wait, going back, let's check down down down. What we have done, we have first second third fourth, first second third fourth, first second third fourth, first first, and that is we have done first second and 0 0 minus 2 0. Okay, 1 2, okay, 3 4, first 2 3 4, 1 2 3 4, no 1 1 3 4 2. So 1 3 4 2 1 3 4 2 1 3 4 2 1 3 4 2. Okay, 1 3 4 2. So 1 2 3, these three are li, na? 1 2 3. So going back. So 1 2 and 3. This is, these three vector form, what I'm saying, Thanu, these three vector form basis of W1 union W2. Is it okay?
सर ये W1 यूनियन W2 का ही फॉर्म करेगा, W1 इंटरसेक्शन W2 का नहीं, ऐसे कैसे पता चलेगा सर?
नहीं, मैंने पहले
तो सारे ही ले लिए ना,
हम
लोगों ने तो सारे ही ले लिए, चारों के चारों ना सर.
एक्चुअली मैंने पहले बताया था कि W1 यूनियन W1 plus W2 is generated by W1 union W2 spanning.
यस सर, पर हम लोगों ने
W2 का ही फॉर्म करेगा.
पर सर हम लोगों ने W1 यूनियन W2 थोड़ी लिया इसमें, तो सारे ही ले लिए थे हम, मतलब ओके यूनियन ही होगा, ठीक है.
W1 plus W2 is generated by W1. Yes. Yes. Yes, tell me.
But the answer was like they have included that two vectors as given in the question. Along with that, they have included the W1 intersection W2 vector. So
W1
first they have found the W1 intersection W2, that vector.
I just want to tell you one thing. Whatever they have done, okay. I think you are saying like this. W1 union W2, you are saying, sorry, you are saying कि W1 plus W2 में उन्होंने कुछ ऐसा include करा है, that is W1 and sorry, these two vector, which is 1 0 1 0, okay, and 3 0 1 0, and that and include W1 intersection W2 vector. Are you saying like this?
Yes, sir.
So actually the problem is what we have done. See, you know W1 plus W2, the dimension of W1 plus W2 is dimension of W1 plus dimension of W2. See, W1 plus W2, okay, W1 plus W2 is generated by W1 and W2, W1 union W2, okay. Whatever vector we have eliminated, okay, whatever value vector, we generally say this is minus W1 intersection W2. This is the concept. Whatever they have done, okay. This W1 plus W2 dimension is dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Okay. Now you are saying, first of all, sir, find out this vector which is generated by W1 union W2. Okay. It means the W1 plus W2 that is generated by W1 union W2. So what we have done, we have told you that this is generated by, but this is not linearly independent. So we have to find out by row echelon transformation, which is linear dependent. As you have mentioned, you do not have to delete these two vectors. At least it means W1 union W2, W1 plus W2 contains at least two elements. These two elements, okay. So we will take care of these two elements. We will not delete, and we will eliminate all the elements. Whatever element elimination is possible. So we will get this one, okay. So if you see this one going back, okay, this is the W1 plus W2, W2 only, the basis of W2. Okay, so W1 plus W2 is generated by this one, okay, this one. It means the dimension of this is, the dimension of this is like you have said W1 plus W2, that is 3. Okay, this is 2, this is 2, and this is, what is this? The dimension is, I don't know what is the dimension. I don't know. Okay, I don't know. Yes or no? Done. So dimension is so can you conclude now? Dimension, if dimension is 1, then what you can say? W1 plus W2 is the element of W2, whatever you have said, plus one element from the intersection. Is it clear, Thanu? Is it clear? Okay, done. So basically W1 plus W2, you know, W1 plus W2 is, that is generated by W1 union W2. And acha, tell me one thing, what is the vector which is generated by W1 intersection W2? What is the basis of W1 intersection W2? What is the basis?
Linear combination of W1 and W2.
Linear combination W1 W2. How?
A vector which belongs to both W1 and W2.
So you will say linear combinations. W1 intersection W2, that is the intersection. That belongs to the W1 linear combination of like W1 and W2 where both are same. Okay. When linear combination of W1 W2 are same, then you can say that vector will belongs to W1 intersection W2. Is it right or wrong? What I'm saying, see, you have W1 intersection W2. What is this? Let us consider basis. You have basis. So you will find out the linear combination of this, and this linear combination is also linear combination of this. You will find out the solutions. And whatever solution you will get, okay, whatever solution you will get, A, B, C, D values, okay, particular. So that will create a intersection of W1 intersection W2. Sorry, the intersection W1 and W2. Then yes. that will belongs to both W1 and W2. It means that will that you can say that is also the linear combination of W1 as well as W2. नेक्स्ट क्वेश्चन, यस व्हाट यू आर आस्किंग, नेक्स्ट क्वेश्चन स्टूडेंट। कोई कुछ कह रहा था अभी मेरे से कि सर मैं क्वेश्चन बताना चाहता हूँ क्या? प्रांशु, यस
Sir, I have a question that change beta dash coordinates into beta coordinates, and beta is
रुको, चेंज
beta dash
कोऑर्डिनेट
into beta coordinate. Beta is equals to x square minus x.
बीटा स्क्वायर, बीटा इज इक्वल टू
हाँ,
एक्स स्क्वायर माइनस एक्स कैसे लिखेंगे?
एक्स स्क्वायर माइनस एक्स, सर ये बेसिस दे रखा है, ये एक्स स्क्वायर माइनस एक्स स्क्वायर प्लस 1 एंड एक्स माइनस 1।
ओके, एक्स स्क्वायर माइनस एक्स
स्क्वायर प्लस 1
1
एक्स माइनस 1,
एक्स माइनस 1 एंड बीटा डैश
इज 5x स्क्वायर माइनस 2x माइनस 3 कॉमा माइनस 2x स्क्वायर प्लस 5x प्लस 5 and 2x square minus x minus 3.
yes student, change beta dash coordinate into beta। क्या करना है इसका, क्या क्वेश्चन आंसर क्या दिया है?
सर एक मैट्रिक्स दी है सर, एक मिनट में बताता हूँ वो मैट्रिक्स।
मतलब क्वेश्चन क्या एग्जैक्टली क्वेश्चन, दिस इज ओनली द क्वेश्चन?
यस सर, यही है क्वेश्चन।
एक मैट्रिक्स और दी होगी इस क्वेश्चन के अंदर?
सर नहीं दी, यही लिख रहा है कि बीटा डैश को बीटा में चेंज कीजिए, ये कोऑर्डिनेट मैट्रिक्स है सर ये क्वेश्चन।
कोई बात
और
नहीं,
आंसर दे रखा है,
आंसर इज मैट्रिक्स।
यस यस सर, मतलब हमें ऐसी मैट्रिक्स बतानी है जो बीटा डैश को बीटा में चेंज कर दे।
ओके, सो आंसर इज गिवन।
यस सर, इट्स 503, कॉलम वाइज लिखना सर। -6 4 -1 सर, 4 -4 नहीं है, 4 और 3 -1 2।
ओके, चलो मान लेते हैं यही है, ठीक है। करना कैसे है ऐसे, ये मैट्रिक्स से कन्वर्ट कर दे, बीटा को बीटा डैश में कन्वर्ट कर दे, इट मींस दिस इज अ लीनियर ट्रांसफॉर्मेशन। वी हैव व्हाट इज द लीनियर ट्रांसफॉर्मेशन? basically you can multiply, this is like t of beta is equal to beta dash, it means you can multiply, like you can multiply, let this is a matrix t, so multiply this is okay, if this is the answer, write down in a column form, if this is the answer, this please check, this is the answer, एक बार चेक करना दो, क्या यही आंसर आ रहा है? t बीटा डैश इज इक्वल टू बीटा डैश। चलिए, so this is clear, so any other doubt you want to ask? No?
हेलो
yes
सर, लास्ट क्वेश्चन में बोला था कि W1 इंटरसेक्शन W2 में वो कंटेन होना चाहिए W2।
नहीं, वो W1 इंटरसेक्शन W2 में दोनों वेक्टर कंटेन नहीं होंगे,
वही तो सर है ना,
वो क्वेश्चन खाली
क्वेश्चन में देखो ना सर,
क्वेश्चन इज दैट कि फाइंड द बेसिस ऑफ W1 इंटरसेक्शन W2 एंड दिस व्हिच कंटेन दिस, मेरे हिसाब से ये था, बिकॉज़ W1 इंटरसेक्शन में W2 में कैसे कंटेन हो जाएंगे, जरूरी कंटेन हो जाएंगे, हो सकता है W1 इंटरसेक्शन W2 में दो ही एलिमेंट हो, एक ही एलिमेंट हो, तो डायमेंशन ऑफ
Yes,
W1
yes.
intersection W2 is only one. So how can you say that कि W1 intersection W2 contain two vector which are Li? That is not possible, na?
Yes, sir. Yes, sir.
Done?
Yes, sir. Done.
Yes, yes. Any other doubt in the linear algebra you have?
सर ये समझ में नहीं आया सर, बीटा डैश वाला ये नहीं आया समझ में सर।
क्वेश्चन का आंसर तो आ गया
सर, वो तो आंसर शीट से आ गया सर, वो तो
आंसर शीट से आ गया।
समझ में नहीं आया सर कैसे आई
अगर
ये
ऑप्शंस है मेरे पास, आई हैव टू चेक दीज ऑप्शंस। सो बेसिकली क्या कह रहा है वो कि लाइक यू हैव सम बेसिस, you have some vectors on the left hand side which transform into this. So what we are saying, we want t into x such that y. So what I have told you, t is a matrix. So what I have done, t of x, and this is the right hand side matrix. So we get the answer. आंसर शीट से क्या है, आप मुझे ऑप्शन दो कि चारों, तो मुझे चारों ऑप्शन चेक करने होंगे बिकॉज लीनियर ट्रांसफॉर्मेशन इज नॉट गिवन।
सर या तो हम ऐसा भी कर सकते हैं ना, px ले सकते हैं, p3r और
कैसे ले लोगे,
p2r।
मुझे एक चीज बताओ, इस क्वेश्चन में, इन दिस क्वेश्चन it is not given what is the linear transformation. Actually we don't know. If you say कि सर हमें we can write down, actually हम लिखते क्या थे मैट्रिक्स बनाने के लिए, t of something is equal to, we can write down the linear transformation of something. Yes, yes, who will speak?
Sir.
Yes, yes, yes,
Yeah,
yes.
I think they have asked the beta dash coordinates to transform in terms of beta. So we can take each element from the beta dash and
That
write
can be
it
written
as
as a linear
combination.
combination of beta. Yeah.
Huh?
You are saying take all these elements from beta dash and that you can write down in the terms of beta. Yes or no? You are
Yes, sir.
saying, sir, you can write down like this also because beta to beta dash. So you are saying, sir, you can take like this. I understand. Yeah. But why? Why? What is the problem? Matrix multiplication is very easy to find out. Why are you finding out all this ABC, ABC, ABC? X square minus x. Find ABC, then further find ABC, then further find ABC, you will find out the matrix. Am I clear?
सर 2006 का क्वेश्चन है।
2006.
Yes. Let t tends to r cube, r cube tends to r cube. Yes. Defined by t x1, x2, x3 equals to x1 minus x2, comma x1 minus x2 0. If nt and rt denote the null space and denote the null space and range space of t respectively, then dimension of n bracket t equals to 2, dimension r bracket t equals to 2, rt equals to nt,
RT
सर ऑप्शंस बता रहा हूँ सर।
इसकी भी डायमेंशन गलत क्वेश्चन।
नहीं सर गलत क्वेश्चन नहीं है, 2006 में आया है और ये वाला मुझे आया नहीं इस वजह से सर।
नहीं इसके ऑप्शन क्या है? ये लिखा हुआ है।
हाँ ये ऑप्शन है, ये ऑप्शन है, ये ऑप्शन बी।
अच्छा बताओ।
ये सेकंड वाला सर, ये ऑप्शन बी। हाँ ये अब ऑप्शन सी, RT इक्वल्स टू NT और ऑप्शन डी NT is subset of RT।
इस क्वेश्चन नहीं किया, जस्ट म्यूट योरसेल्फ।
सर ये लाइन नहीं है, सबसेट के नीचे ये लाइन नहीं है। सिर्फ ये yes
mute. Yes student, please solve this question. See, this is the, so you can find out the null space is easily. The null space is x1 minus x2 is 0, then x1 equal to x2. So if x1 equal to x2, null space, what is the null space? X1 is equal to x2, so you have a null space NT of x1 x3. So null space dimension is 2. This is clear. This is wrong. Why this is wrong? Because the dimension of RT is 1, range space 1, because null space is 2. Yes or no? Dimension of RT and null T कैसे आएगा? Null space is a subset of RT. RT is lesser dimension. This is right. So answer number 1 is correct. Yes. Jinesh, what is the problem in this question?
इस टाइप के क्वेश्चंस में सर हमें ध्यान क्या रखना होता है, किस बात का मतलब मेन?
तो ऐसा है, इतना सारा काम करा दिया, इसमें ध्यान रखने वाली कोई बात नहीं है। सिंपल, यू हैव टू फाइंड आउट नल स्पेस व्हेन t x1 x2 x3 is 0. नल स्पेस से मुझे अभी थोड़ा डाउट है कि तुमने नल स्पेस रेंज स्पेस सही से नहीं पढ़ा। नल स्पेस ऑफ t इज नथिंग बट, सॉरी मैं कहना पड़ रहा है बट, क्योंकि दिस इज द रियलिटी और दिस इज वेरी बेसिक क्वेश्चन such that t alpha is 0. So you can find out null space here. So t alpha is 0. Isme t alpha is this one. This is you will put down that 0. So you will have only two condition. One condition x1 is equal to x2. So null space is all those x1, x2, x3 such that x1 equal to x2. So you will have x1, x1, x3. So this is a subspace of R3 which has dimension. What dimension? Which has dimension 2. So null space has dimension 2. Okay, so range space is 1. Why? Because range plus null equal to dimension of left hand side vector space, a final dimension. This is very basic. This is by the help of definitions. क्या ध्यान रखना होता है इसमें कुछ नहीं कह सकते। क्यों? क्योंकि इसमें कुछ ध्यान रखने वाली बात ही नहीं है। This is very simple. Am I clear? Any other problems? Yes. Any other problem you are facing in linear algebra? Yes. No problem. Chaliye. So we have some problem. We will discuss some problem more. Let P, D and A are real square matrix of same order such that P is invertible, non-zero, and D is diagonal such that diagonal matrix with D is equal to P inverse if A raised to power n is 0 for some n belongs to n, then A is equal to 0. This is true or false?
Sir,
This
a
is
matrix with zero eigenvalue cannot be diagonalizable. A matrix with a zero eigenvalue is not diagonalizable.
A matrix with the zero eigenvalue cannot be diagonalizable. How? This diagonalizable, no? This is the matrix which has zero eigenvalue and this is diagonalizable. How can you say?
Sir,
Yes, yes.
if a power n equals to 0, then this implies that A is a nilpotent matrix, and nilpotent matrix is not diagonalizable. Only it is
Diagonalizable
diagonalizable.
when A is zero.
Yes.
Diagonalizable. This is the main thing. A की power n is zero. It means A is nilpotent matrix, and nilpotent matrix is never diagonalizable. Matrix is either nilpotent or diagonalizable. Okay, diagonalizable हो nilpotent नहीं हो, nilpotent और diagonalizable दोनों जब हो सकती हैं जब matrix is zero. And second method is you can also write down because D की power n is equal to P A की power n and P inverse. Yes or no? Yes or no? And you are saying कि this is P and A की power n is zero. So that is, so it implies this is, what is this? This is zero. It implies D की power n is zero. A diagonal matrix की power n is zero. It means this diagonal matrix itself is zero. Yes or no? Am I clear or not? D की power n is equal to P A की power n P minus P inverse. A की power n is 0, P 0, P inverse is 0, D की power n is 0, D की power n is 0, it means D is 0. If D is 0, what is this? D is 0, then A is also 0 because A is equal to PD P inverse. It means A is 0. Yes or no? Yes, Hanu, you can speak now. What do you want to say?
Exactly what I wanted to say was now you said, sir.
Okay. Is it clear, student? Next problem is, let A n cross n matrix real symmetric matrix with n distinct eigenvalues. Then see this problem. A is real symmetric matrix with n distinct eigenvalues. N distinct eigenvalues you have. Okay. A is real symmetric matrix with n distinct eigenvalues. Then there exists an orthogonal matrix P, such that AP is equal to PD, where D is a diagonal matrix. Is it right or not? Yes. Why? Because symmetric matrix is always symmetric matrix is always diagonalizable. If that is diagonalizable, that it can be written as a P inverse AP. An eigenvector are, what is eigenvector? This is a matrix from eigenvectors P. This is matrix from eigenvectors. And eigenvectors are orthogonal. Eigenvectors are orthogonal. Yes or no? Orthogonal. So if this is orthogonal, you will find out this matrix is orthogonal matrix, because this matrix has n distinct eigen and distinct that is diagonalizable to वैसे भी, if not distinct, that is also diagonalizable, and you can write down that is orthogonal matrix P. P is the set of all, P is the matrix which is formed by all linearly independent eigenvectors found by that eigenvalues. Am I clear? Is it clear to you, all of you, student? Any doubt? Chali, you have one question. Yes, you can ask. If you have any question, you can ask me. Yes.
Sir, please write down.
Yeah.
Let A of theta is equal to
Let
A of theta
A of theta
is equal to, it is a 2 cross 2 matrix, sir.
2 cross 2 matrix. Yes.
And entries are cos theta minus sin theta, sin theta, cos theta. Theta belongs to 0, 2 pi.
Open, close.
Open, sir.
Open.
Which of the following statements are true? A of theta has eigenvectors in R square.
Eigenvectors in
R square
R square.
for every theta belongs to 0, 2 pi. A of theta has eigenvectors in R square for theta belongs to 0, 2 pi. In first option, for every. In second option, for any. Third option. A of theta has eigenvectors in R square for exactly one value of theta belongs to 0, 2 pi. In D option, exactly two values of theta belongs to 0, 2.
Well, yes. How to find out the answer to this problem? First of all, as I have seen this problem, this is an orthogonal matrix. This is a rotation matrix, the transpose of a rotation matrix. Do you know this one? We have already discussed one thing. A theta, this is cos theta sin theta minus sin theta cos theta. So this is a rotation matrix, we know, and the rotation matrix, and this is the determinant is 1. Okay, and this is an orthogonal matrix also. A transpose equal to Y. Okay. Yes or no? Orthogonal matrix. Now what you can say about? Okay, this is also orthogonal. Check. If A is orthogonal, A transpose is also orthogonal. This is A transpose. Student, whatever we have rotation matrix, so this is also the transpose of a rotation matrix. Okay. Yes or no? फटाफट बताइए. This is the transpose. This is also orthogonal. Yes. Now the question is, what are the eigenvalues of this? What are the eigenvalues of this? Yes. What are the eigenvalues of this? What you can say? What is the eigenvalues of orthogonal matrix? What are the eigenvalues of orthogonal matrix? बताइए.
+-1
+-1. पक्का?
A trans, yes sir, A transpose equal to I होता है ना orthogonal.
A transpose equal to I. So eigenvalue can be complex also.
No sir. Square equal. No sir, I don't think so.
Why?
If we take both side determinant, then I don't know, I have to check, I think.
Thanu saying cos theta plus minus sin theta in this matrix. Cos theta. No, I'm not getting. Thanu, what you are saying? Cos theta. Okay, Thanu is saying, sir, cos theta plus sin theta or cos theta minus sin theta is the eigenvalues. Okay. So what you can say about? Ajay, tell me one thing. The orthogonal matrix. Eigenvalue of orthogonal matrix can be imaginary. First question. Eigenvalues of orthogonal matrix can be imaginary. Eigenvalue are of unit modulus. Unit modulus. Unit modulus का मतलब क्या होता है? Determinant is real. So determinant is real. Let us consider determinant is real 1. So we can find out I and minus I. Say I minus I square and minus 1 into minus 1, answer is 1. How can you say this is not 1? Yes, Pranshu, you are wrong. Determinant is real, then you cannot say that the eigenvalues are real. Determinant is the product of eigenvalue and two complex number product is also a real number. That can be a real number. Yes. Thanu, what you are saying is orthogonal matrix has a real eigenvalues. Okay. Acha, or you know the symmetric matrix has a real eigenvalues, and skew symmetric has eigenvalues are either 0 or purely imaginary. Orthogonal matrix are eigenvalue real. Unitary matrix has eigenvalues as a unit modulus. Unit modulus means because that can be unit modulus, that can be lies on the circle. Can we say? So if orthogonal matrix has a real eigenvalue and determinant is +1 or -1, so is there any possibilities of eigenvalues of orthogonal matrix? Only real eigenvalues? Yes or no? Yes or no? Is it clear? Orthogonal matrix has real eigenvalues. Is it clear to all of you? Yes. Can you tell me what is the eigenvalues of orthogonal matrix? What are the eigenvalues of orthogonal matrix? Can you give me, can you tell me, जैसे हम कहते हैं कि idempotent matrix has only eigenvalue 0 and 1, nilpotent has only 0. Can we say something about orthogonal matrix? Entries are real, so eigenvalue is real. Entries are real. एक मिनट रुक जाओ, पहले मैं ये बात क्लियर कर देता हूँ क्वेश्चन प्रांशु का. Entries is real, then eigenvalue is real. Who told you? Entries are real. Matrices are from M to R. What are the eigenvalues? Characteristic polynomial. Pranshu. Matrix entries are real. It does not mean that the eigenvalues are also real. ठीक है? That can be complex also. Is it clear? Number one. Done? Okay. अच्छा, tell me, जो क्वेश्चन मैंने पूछा है, can you say anything about the eigenvalues of orthogonal matrix are this? Can you say anything about?
Sir.
Yes.
Eigenvalues are only +1 and -1. It cannot be like imaginary for orthogonal matrix.
Why?
Because sir, AA transpose equal to 1. So if we take determinant, no sir, if we take determinant both sides, then we find that the determinant of A and multiply with determinant of A transpose equal to determinant of I.
ठीक है.
And like determinant of I cannot be the imaginary, sorry, I can say that कि हाँ imaginary नहीं हो सकता, तो 1 ही आएगा वो तो determinant. तो हम जब square root both side करेंगे तो जब वहां पर 1 ही है तो +-1 ही आ सकता है, I तो आ नहीं सकता. तो
उससे क्या होगी?
तो सर इससे ये सिद्ध होता है कि I नहीं हो सकता इसका कभी भी. अच्छा. ऑर्थोगोनल मैट्रिक्स का डिटरमिनेंट I नहीं हो सकता. ओके. सॉरी, इसका ऑर्थोगोनल मैट्रिक्स.
तो ये होगा. ठीक है. तो आइगन वैल्यू +1 -1 होगी. अच्छा. और डिटरमिनेंट किसी का 1 है तो उसकी आइगन वैल्यू +1 और -1 होगी, पर +1 -1 दोनों होगी हैं.
नहीं सर, बिकॉज मैट्रिक्स इज I ना, दैट इज व्हाई.
नहीं ठीक है. अब इसकी आइगन वैल्यूज बता सकते हो, आइगन वैल्यू क्या होगी?
इसकी आइगन वैल्यू को तो सर कुछ कह ही नहीं सकते. अगर डिटरमिनेंट ऑफ
मे बी आइगन वैल्यू दैट 1/2 and 2.
आई डोंट नो सर, पर लेकिन ऊपर वाले के लिए मैं श्योर हूँ, ऊपर वाले नीचे वाले को कुछ कह नहीं सकता.
Done. Okay. So it means eigenvalue is real and +-1. Okay. You cannot say anything about. We're done. चलो ये बात तो हमारी क्लियर हुई इस क्वेश्चन की हेल्प से. It is a square of matrix. Yes. Done. No problem. I was just asking you just do you know something or not. Yes. Now the question is, a theta has eigenvalues in R square for any theta. Yes. For any theta के लिए आइगन वैल्यूज मिलेगी इस मैट्रिक्स की. सॉरी, आइगन वेक्टर मिलेगा. एक ही वैल्यू के लिए आइगन वेक्टर मिलेगा, सारी वैल्यू के लिए मिलेगा, क्या किसी एक के लिए मिलेगा? What you can say about, फटाफट बताइए 1 मिनट के अंदर. I am giving 1 more minute for this problem. Now student, you know this is a matrix which is orthogonal. Yes or no? Orthogonal matrix has real eigenvalues.
Sir?
Yes.
I think the theta for which the determinant gets +or -1 will be the answer.
+1 and -1 is?
The value of theta for which we will get +or -1 as the answer. Maybe the...
No. What I am saying, student, कि this is orthogonal matrix. Orthogonal matrix has determinant +1 -1? Yes or no? What are the, sorry, leave it. What are the eigenvalues of this orthogonal matrix? Real? Just for reminder. Yes, yes, yes. Sure, sure. See, you have this matrix A, and this matrix is orthogonal matrix. Is it clear?
Sir.
Is it clear? Anybody want to say anything?
Yes, sir.
This
That
matrix,
actually,
yeah.
if the elements are real, then always in an orthogonal matrix, eigenvalues will +1.
Eigenvalue +1.
Yes, sir.
So leave it. I am not saying about eigenvalues. I am just telling you some other thing. Eigenvalues are of orthogonal matrix are real or not? Yes or no? Eigenvalues of orthogonal matrix are always real. Yes or no?
Yes, sir.
Is it real?
Yes.
Yes.
Eigenvalues of orthogonal matrix are always real. Why? This is very much clear. If you take a real matrix, see, this is very much clear. Don't be confused about this. You have A transpose equal to I. You are saying determinant of A transpose equal to I. Determinant, this is 1. Determinant of A is a real number. Okay. This is a real number. Determinant A transpose is also a real number because all the entries are real. All the entries are real. Real का determinant real. Real का determinant real. Real square real equal to 1. So determinant of A square is 1. So determinant of A is 1 +-1. That will give only the only determinate, nothing else. Determinate is only +-1. That will not give you the eigenvalues, and eigenvalues is governed by Ax equal to lambda x. Okay, and if you multiply A transpose lambda, कुछ ऐसा कर सकते हैं क्या हम? A transpose of lambda x and lambda of A transpose x, and that is A transpose A equal to ix equal to x lambda. अच्छा, A transpose x, A and A transpose has same eigenvalues? Yes or no? Do you know these things? Are you saying like this? A transpose x equal to also lambda x. So lambda square x -1 is equal to 0. Lambda square -1 is equal to 0. Lambda is equal to +-1. घर पे जाके एक बार चेक कर लेना. Just try to find out the answer in this way. So lambda is equal to +-1 like that you are saying. Is it? Okay, just go and check. I am not telling you, just go and check. But my main thing is orthogonal matrix has real eigenvalues. If real eigenvalues, then you will find out the eigenvector. How to find out eigenvector? Eigenvector is A minus lambda I of x equal to 0. Eigenvector is the solution of this. If A matrix is real, lambda is real, I is real, this is a real matrix. Real into x equal to 0, real into x equal to 0. So this is the kind of bx equal to 0 for any theta. Any theta, this is a bx equal to 0. Bx equal to 0 has always real solution in R square. Yes or no? It means eigenvalues are real. Eigenvalues are real, and eigenvalues are real, and eigenvector also belongs to R square for any theta. I think this is correct. Yes. For every, for any mean for every. Yes, Shyam Reddy. Shyam Reddy. C is given. Answer is given for exactly one value of theta. Okay, I will check. Then I will check. A theta has eigenvalues in R square. Just a minute, just 1 minute. A theta has eigenvalues in R square for theta belongs to 0 to pi. एक मिनट. Yes, yes. Yes, there is some problem in this question. Wait. You are saying right. See, if you take theta is equal to pi by 2, theta is equal to pi by 2, it has complex eigenvalues, student. मैंने पूछा क्या ये मैट्रिक्स ऑर्थोगोनल है? एक मिनट, वेट. क्या ये ऑर्थोगोनल है? एक मिनट ना, तुमने मुझे आंसर ही गलत बता दिया. दिस इज आई थिंक नॉट ऑर्थोगोनल. वेट. cos theta minus sin theta, sin theta cos theta. Is it orthogonal? Cos theta sin theta minus sin theta. A transpose. A transpose. Cos square theta plus sin square theta 1. But this is orthogonal, yes. Yes, cos theta plus sin theta minus sin theta is 1. And this is cos theta sin theta minus sin theta cos theta sin theta cos theta sin theta sin square theta. This is orthogonal matrix. It means orthogonal can have eigenvalue real complex. Yes, problem has been solved. एक बार पीछे प्रतीक्षा ने बोला था, प्रतीक्षा ने क्या कहा था कि कॉम्प्लेक्स आइगन वैल्यू हो सकती है मॉडुलस लैम्डा इज इक्वल टू 1. प्रतीक्षा, यू आर सेइंग लाइक दिस ना, मॉडुलस वैल्यू. बट व्हाट वी हैव प्रूव्ड, मैंने भी कहा था घर जाके एक बार चेक कर लेना इसे. यहां से तो हमने लैम्डा इज इक्वल टू प्लस माइनस 1 निकाल दिया, पर यहां पर कोई फॉल्ट है. yes, at least you want some counter example. Yes, you can take it right now. लीजिए, क्या ये ऑर्थोगोनल है? देखना जरा. दिस इज ऑर्थोगोनल. yes or no? Is it orthogonal? Just a minute. You have class at 8:15 na, so I have to wind up at 8:02. So orthogonal matrix can have complex eigenvalues. Real. मैं जब से आपको यही समझाने की कोशिश कर रहा था कि नहीं होता, but you were saying sir yes. So that's why I have proved yes. Now finally I have given you answer. I have given you counter example of this one. So orthogonal matrix can have, real orthogonal matrix can have eigenvalue complex. So एक बार इस चीज को पढ़ेंगे, घर जाके देखेंगे कि सर कैसे, how did you find कि orthogonal matrix can have complex eigenvalues. Okay, orthogonal matrix can have
सर.
yes,
मुझे लगता है
yes.
इस एग्जाम्पल में हम लोगों को एटलीस्ट ट्राई करना पड़ेगा कम से कम 3 निकालने का.
मैंने मेरा क्वेश्चन इस एग्जाम्पल को कराना नहीं था, खाली मेरा क्वेश्चन 2-4 कंसेप्ट और कराने थे. आपको ये देखा, आपने देखा ऑर्थोगोनल मैट्रिक्स. अगर ऑर्थोगोनल मैट्रिक्स की सारी आइगन वैल्यू रियल होती, लेट अस कंसीडर ऑर्थोगोनल मैट्रिक्स हैज ऑल रियल आइगन वैल्यूज, देन व्हाट यू कैन से, you can say कि this minus lambda into x has real solution. It means orthogonal matrix, a matrix which has real eigenvalues, have real eigenvector always. Yes or no? This is the main concept. If a matrix has real eigenvalues, then real eigenvector. Yes or no?
Yes sir. सर मैं क्या कह रहा था ना कि हम लोगों को ना एक एक करके थीटा की वैल्यू रख के कम से कम 2 आइगन वेक्टर निकालने की कोशिश करनी चाहिए.
No. If you take theta is equal to pi by 2, this matrix will be converted into a one matrix which is a orthogonal, but this matrix is not having complex eigenvalues. And if you take theta is equal to 0, then what will happen? If theta is equal to 0, I has real eigenvector. So it means that's why this is not the answer, this is the right answer, exactly 1. And you can check also. Okay. First of all, just go and understand what are the possible values of eigenvalues of orthogonal matrix. Orthogonal matrix can have real eigenvalues.
Actually 0 तो हम रख ही नहीं सकते. Yes. नहीं तो अभी प्रूव रॉन्ग हो जाता ना सर, अगर 0 तो रख ही नहीं सकते ना हम लोग।
हाँ, 0 रख के, फिर 0 रखते एग्जैक्टली 2 आ जाता।
हाँ एग्जैक्टली 2 आ जाता।
ठीक है ना, वो फिर प्रॉब्लम देखनी पड़ेगी, ऐसा ना।
जी जी
यस, ओके, डन।